Hi, this is Brent with Theoretically Practical, and today we're at a friend of mine's shop where we're going to be putting a single-phase VFD on this old Bridgeport Tektron CNC machine. Now, the reason why we're putting a single-phase VFD on it is because in this particular case, this machine's already had a Centroid conversion applied to it. We'll go around and look at that in a minute. So it already runs basically off a plug for all the axes and everything but the spindle motor. The original plan was to run this off a phase converter, but when my buddy figured out that all he actually needed was a single phase VFD and the whole thing would just work off single phase, well, that became the ideal answer. So this is a 3 horsepower spindle, and the drive we're going to be using is also from Automation Direct as per normal. And this is a WEG brand CFW 300 vector inverter. It has a single phase input of 22 amps and a 3-phase output of 10 amps, 0 to 400 hertz. So this is just a regular drive. Now, basically there's just gonna be a run forward, a run reverse signal going to this, and a 0 to 10 volt signal for the RPM. This machine won't be capable of interpolating, which is controlling the rotation of this axis. It can only spin it on or spin it off. So you could do thread milling in it, but you wouldn't be able to do threading in it per se. So we're gonna run back. I'll show you what's in there now, and yeah. Okay, so I've seen a few different flavors of Centroid Retrofit, mostly the Centroid Oak. This is 395S or whatever. There'll be a picture of the nameplate that's on the machine from the Retrofit. So what this is basically just a standard PC. It's just a little different because it's in an industrial environment. It also does some of the ins and outs of the servo drive, like these 3 cables here are the 3 feedback from the servo, and then it's got some optical stuff going on for communicating with this unit here. This unit is a 3-axis servo drive with the PLC for the machine in it as well. And why there's an extra fiber optic jack that's not plugged in, I don't know. This conversion was probably done a while ago. These are usually done by semi-professionals. I would say, looking at this is not a terrible job, but a lot of things could be a lot neater and better labeled in here. I know that the machine moves around and does basically everything it needs to do except turn the spindle on. So I know if you haven't done this stuff before, you look in here and, oh man, this is intimidating. There's wires here, there's wires there. These aren't terribly labeled, and you know, there are some labels on things. There should be some wiring diagrams, and you just have to work your way through it slowly and methodically. You know, the biggest thing I could say about wiring is it's way easier to spend all the time it takes to wire it once correctly than to wire it several times poorly. So this isn't a machine I would use in a production environment, but in your own garage shop, this is about as good as it gets. After puzzling it out, this disconnect is wired in the weirdest way possible. So your 220 volt 3-phase, which was originally for the VFD, we're going to be switching that to single phase, but the power comes in, goes through the circuit breakers, goes into the output of the disconnect, and then out through the input of the disconnect. While this is wrong, it's not dangerous per se, I don't think. If you think different, let me know in the comments. But then on the other hand, the 120 volt input is this wire here, and this comes up and goes in this side of it, and then goes down here. So you got the 120 volt going the opposite way of that. That's a problem because these 2 wires are for a 24 volt power supply that has to do with for the solenoids for the tool changer, the release on that. So we're going to be moving this to the neutral will go there and the hot will go there, so that this is on a protected circuit and not just on an unprotected circuit. Other than that, yeah, there's going to be one going this way and one going that way. These 2 are like little separate contactors that you can add on to it, so you can do something just like this. This is an appropriate use for this switch. It's just wired backwards from what I would expect. So it's not the end of the world, but it's not the greatest thing either. So this is the current 3-phase VFD. For those of you that are interested in what was on there, it is an Omron SysDrive 3G3MV inverter. So we're gonna have to take a good look at the input terminals to make sure that we know what we're doing there. The rest of this is really pretty simple. So, okay, so I've gone through, I've looked at what all of these input terminals do, so I'm ready to disconnect them. I've also gone through the manual for this drive, and I've written up this map. I know what my forward is, my reverse is, my reset is, and my sequence are common. So I'm gonna disconnect those, and I'm gonna label them as forward, reverse, reset, sequence common, 0 to 10 volt, and frequency common as I disconnect them. I know that I've also written down the numbers on the wires, but you just can't be too careful. Again, troubleshooting wiring is so much worse than just doing it right the first time. This is also a weird way, because this wire should kind of go through there or around there and not kind of through the side of the plastic. And also it shouldn't be doing other stuff. I don't know. I don't love it, and there's a lot of, you know, heat shrink solder joints in this. What I suspect is that somebody bought this cabinet, the big cabinet below we've been looking in, from Centroid, gave it to their maintenance guy, gave him the machine and said, hey, make it happen. What's the worst that could happen? And it worked, but it could be a lot nicer. That is the wrong screwdriver. And I'm sure you'd be disappointed if I didn't, we'll be putting ferrules on all these to make the connections work well. It's also 65 degrees in here, so I don't need a jacket, which is fantastic. This is just another sign that this was somewhat of an amateur job. I would never use ring terminals in this application because they're a pain in the ass to take out. And again, a ferrule, the way these are designed, these little screws on here, they've got these little cutting edges in them, and your ferrule's not gonna squeeze out the side or anything, but you'll get a really nice contact with these and still maintain really good serviceability. So we'll just pull all these out. Oh no, oh no, oh no. All over the place. Well, I guess we're still filming. These also don't fit through holes. They're just, this is the wrong, you gotta use a ring terminal for the ground. There's not much you can do about that. But these, we'll switch these over to ferrules because it's just such a pain for no reason. And the beast is free. Get everything ready to mount the other drive up, and then we'll connect it up. And that's really that simple. It's just, you really want to take the time to look at all your connections and know what they do and what you want them to do on the new machine. Okay, so this WEG drive is a little bit different than the other one in that instead of having all the terminals at one end, you have the inputs at the top and the outputs at the bottom. I see this more and more often. It just depends. There's all sorts of different flavors of everything. The terminals at the top are PE for permanent earth, line 1, 2, and 3, but we're only going to use 2 of those. We'll have to check the manual. It's usually 1 and 2 if it's single phase, but sometimes it's 1 and 3. There's plus UD and minus UD. That's if you're going to run this drive off of DC, which is possible, but we're not doing that today. Underneath this cover, there is what looks like a USB-B port, and it says USB not compatible. Don't plug your USB into that. I think it would be probably hilarious. You'll notice that unlike the other 2 drives, this doesn't have a potentiometer. I've taken this plate off, and I suspect there's like a little remote operation plate you can put there, but he doesn't have it because he doesn't need it. So, and then here's where we're gonna be putting in all our buttons and fiddling with things. These are our terminals, 1 through 10. We'll talk about those in a minute. And then this is our output. Again, PE for permanent earth, UVW, and then the braking resistor, which this machine does have. You just hook it up to there and there's no settings, that's it. Braking resistors are very simple. Okay, so we've got our 32 millimeter DIN rail mounted right there. This has a clip on the back. You can also, I think, push these feet out and screw whatever. We're not doing that. We're gonna use the DIN rail because it's gonna make life easy, especially if you have to take it off and remove it, which we probably don't need to do, but it's something to think about. Now, one thing you might be asking is, why is the VFD mounted up here? It's not a great environment for it. It's sucking air through it. Now, obviously, the old one lasted many years, but this is not where you'd want to put it. The problem is that these make a lot of noise electrically. And if you put it in the box below with the PLC and the computer in it, you may not have problems right away, but you will eventually have problems. I've worked on a lot of machines where that sort of rule of, my typical rule is you have a high voltage cabinet that stuff like this goes into, and a low voltage cabinet for all your VFDs and whatnot, not VFDs, for all your PLCs and computery stuff in there. I've had one of these in a cabinet with a bunch of the low voltage stuff, and you get all sorts of weird errors and problems. It was something that somebody else put together before my time, and now I do everything I can to minimize putting these in the same cabinet, because you're basically putting a noisy device in a Faraday cage with another device that doesn't like noise. You don't want to do that. So that's why it's banished up here. It's out of the way. This is going to be a fairly clean shop. So it's not really a problem. They do make a version of this that was sealed. So it's just a sealed IP whatever box, or NEMA 4X, some sort of sealed box. That would have been more appropriate for this application, but the most important thing was wrong with it. It was out of stock. So we got this one, and this will be just fine. So on the feed wire, the VFD power wire, I have taken out the white wire and just cut it off, because I just want to make sure you want it out of the way. It makes implications better. On the output side, we got this cable here, and we'll have 1, 2, and 3. And again, if it rotates the wrong direction from what we think, we'll just swap any 2 of these wires and that will fix the problem. You also notice these wires aren't tremendously huge, but these wires are. And probably whoever was putting this together just used whatever they had lying around. This is 10-4 wire. This is definitely overkill for this application, but which is going to give us trouble with the ferrules, and it's going to give us trouble with fitting it into the terminals. I've made the mistake of using bigger wire because bigger must be better. Bigger is more. It's not. It'll cause you problems. So we'll fight our way through that and we'll get this good. I'm going to hook these in to the back and then clip it in place, because it's the easiest way to do it. There is braking resistor, like positive and braking resistor, but it doesn't matter. It's just a resistor. It has no polarity. It's just a place for this to dump excess heat, which will let you put a higher deceleration rate. In our previous video where the drive would have tripped from decelerating too hard, the braking resistor, which is a box over here, and it's just a big resistor, will take that heat, and it's actually cool. I have put a lot of heat into them before and looked at them with a heat vision system or a heat gun, and as you're trying to slow down a big load, you can just watch them heat right up. There we go. I actually don't like the way they ran that. We're gonna disconnect it and run it a different way. You do this a lot when you're wiring these things. You just end up, doing it over and over and over again, but you only have one chance to get it right. So get it right once. Do it right. Okay, so it's all wired up. If you look in here, there's our control terminal wiring. If you look down here, here's the other wiring. If this all works out and you know, we know we're gonna keep this and this is gonna be on this machine, I'll probably drill a hole in the cover and just zip tie the control wires up. I just don't like them laying on the high voltage wire. If you do need a control voltage and a high voltage wire to be close together, don't do something like that where they're parallel. You get more induction. You'd rather cross it at right angles. That'll help a lot. But that's why I'm kind of just gonna tuck this to the side, and if I get a chance, I'll, you know, zip tie it up here, and they'll be nice and away from all that, and then we'll bring this other wire down here and zip tie it, so it's kind of, you know, just to keep the most amount of separation. These aren't communication wires, so it's not as big of a deal, but good practice is good practice, and you should always practice good practice until you get it perfect. All right, so we're back, and everything is connected up. It's working finally. I did a little bit of troubleshooting, and the quick start guide I followed was not very good. I ended up going into the programming manual, but basically there were a few things that were a little confusing, and of course where you set the maximum frequency, there's a decimal place, which meant I had set the maximum frequency to 1/10 of what I wanted to, which is pretty annoying because none of the other frequencies have decimal places. So be warned, I was at an angle and I couldn't see the bottom of the number. So it is what it is. But we're started up now with the CNC set up for the tallest man in the world. I don't know who ran this, but he was taller than me. And we'll go to MDI and do a S1500 RPM and then an M03. And that's it. It's working great. It makes the right noises. We played around with acceleration and deceleration, and we actually got some smoke to come off the burnt oil on the braking resistor, which is fine. We didn't go aggressive with it. We just left it at just a little bit of smoke coming out the top. Hey guys, so we're going to try to engrave Theoretically Practical in this piece of extremely expensive material, which may or may not be garbage wood. I won't lie to you and say this is our first shot, but it's not our 100th shot. So, let's go. And there you have it. It's Theoretically Practical. And that wraps it up for today. If you like this video, like, comment, subscribe, and have a great weekend.